are moving on to 4.3. We did 4.2 for 3 days, and it was a beast of a section. You know, yesterday, that last example where you had to take 2 points, find the slope, plug into slope-intercept to find the b, then take that m and b, put it in slope-intercept, then move it to standard form, then fix the standard form. I mean, that was a crazy problem, okay? I'm just now looking at our next test is next Wednesday, so I'm putting together the review that the county gives me. So I'll give you a better idea when I get a chance to look at it. It's sitting right here, just picked it up off the printer. I'm pretty sure they're not going to give you one of those on the test with all those steps, but I will double check it just to make sure. Now, all the little pieces in that one big problem are important. We have to know the slope formula. It's not going to be given to you. It's not on the formula sheet. That comes up in our lesson today again. You have to be able to put things in slope-intercept form. You have to be able to identify an M and a B in slope-intercept form, all that stuff, okay? So even though that last problem yesterday was awful, I don't see having a human Okay, so anyway, today is much, much easier, okay? In fact, the very beginning of this, I think you guys are going to find to be really, really easy. So this is, and I see a lot of the questions that I'm about to explain to you on this review, so I'm hopeful that they give you a lot of those questions on your Module 4 test, because you're going to like these. Everyone's going to get these right, okay? Now, it takes me a minute to read. I have to read all this to explain it, so just stay with me while I'm reading. Bivariate data consists of pairs of values, okay? So guys, that root, or I don't know what you call that prefix of that word, bi, bi, you know, think of bicycle, two, binomial means two, bivariate pairs of values, okay? So 2 values. They're ordered pairs, you know, an x and a y. A scatter plot is a graph of this type of data that consists of ordered pairs on a coordinate plane. Let's jump ahead and look at these 3 graphs. Those are scatter plots. They're all just points graphed on a coordinate plane. And notice they're not connected with any kind of smooth line. They're just all these, not random, but points, okay? Using a scatter plot, that's what these are, can help you see the trend or general pattern in the data. Trends can be used to determine associations in the data. Associations describe the form, direction, and strength of the relationship between the 2 variables in a bivariate data set. Sounds very complicated. I promise you it's not. I tell you guys all the time, I will tell you when something is challenging, this is not going to be one of those things. Okay? Different types of descriptions of associations include, does it look linear? Like, does it kind of make a line? Or non-linear? That's one thing we could talk about with these. We could say it's positive, negative, positive or negative, or neither. Like, does the graph look like it's got a positive slope or a negative slope, or neither? And later we'll talk about the strength of it. Is it strong or weak? And I think that's in tomorrow's lesson. It's not today, okay? So look, let's talk about correlation right here. So you see all these points that are on here? It doesn't make a perfect line, right? But it roughly, very roughly, does look like as x's increase, y's increase, which is just like having a positive slope, right? The data is trending in a positive direction versus this one, clearly not a perfect line that's decreasing, right? But you could roughly say it looks like it mostly has a negative slope. Whereas here's an example of one that has no correlation, okay? So that's one of the types of questions you're going to have. Looking at a graph. So first thing is you don't have to make any of these graphs. These graphs are given to you, but they're just a bunch of ordered pairs. And can you say positive, negative, or none, or neither, okay? Second is being able to say in a real world context, in a word problem, what does it actually mean? And that's also not difficult. So let me show you what I'm talking about. The scatter plot right here displays the height and weight of New Orleans Saints football players. Determine whether the scatter plot shows a positive, negative, or no correlation. And then if the correlation is positive or negative, describe the meaning in the situation, okay? So as annoys me with this book, they answer the question for us instead of letting us answer it. But anyway, I mean, this is not even as clear as this one was positive, but roughly it looks like a positive correlation, okay? In other words, as the height of the football players increase, what happens to the weight? Does it increase or decrease? It increases. As the height gets bigger, as the height increases, the weight increases. That's what that means. So as the height of the football player increases, weight usually increases, which kind of makes sense, right? Are there ones in there that break that rule? Of course, okay? In real world scenarios, you're never, or I don't think you would ever, it'd be a very big coincidence, it would never be like a perfect line. It just is trending, is what we say, to be as height gets bigger, so does the weight, okay? So let's look at the check on the next page. This is what the most of your homework is going to be like. You're going to be given a scenario, a word problem, and a scatter plot. And we're going to do two things, okay? So let's read it. The scatter plot displays the number of landline telephones in the United States in 100 million since 2000. So, landline phones, in case you don't know, is when you have a phone in your home, not just cell phones. Some people still have landlines, some people have both, some people just have cell phones, okay? So it makes sense that it's decreasing here, right? As time goes on, as time increases, right, as time passes, what's happening to our y values? They're decreasing, right? As x's increase, y's decrease. That is showing a negative, right? Look at it. It's trending to have a negative slope. So that's called a negative correlation. Big words for just a negative slope, okay? So negative correlation. So the second part of the homework, let's pretend that it's not there. You have to write in your own words, spelling and grammar doesn't matter for me, what that means. Not just that it's negative. Well, as years, so you want to use the word, as years increase, right? As years increase, what is the y values? Number of landlines, and you guys just said it, decrease. So you have to be able to give me just a short little blurb, little quick sentence about what that actually means in the context of the question. And your scatter plots are labeled. So you know what the x values are, you know what the y values are, and you just give a sentence. Okay? So that's the majority of your homework, is that. All right? Now, let's go to the second part of your homework. And this is where we will be doing a little reviewing of the stuff we've been doing the last few days. So let me read to you a line of fit. Okay, that's a term, is used to describe the trend of the data. Like, for example, you guys just said that this was trending, it's a negative correlation. So if you had to say what type of line this is, you'd say it's a line with a negative slope, okay? And what a line of fit is to, like, let me just use this as an example. If I had to make a line of fit in this, if I asked everyone to make a line of fit, what I would be saying to you is make a line that goes through most of the points, okay? It's very hard there's no way to hit all of them, and everybody's graph could be slightly different. So there's not really a wrong way of doing it. Like, for example, maybe that would be my line, right? It's kind of hitting a lot of the points. Now, you do not have to come up with a line of fit. It's going to be done for you. I just want you to understand where it came from. A line of fit here maybe would look something like this, right? And you wouldn't be able to put one there. This has no correlation. It's not positive or negative, all right? So a line of fit is used to describe the trend of the data in a scatter plot. So you're going to be given a scatter plot. There's going to be a line already drawn for you. And here's the work that we have to do. We have to write an equation. And remember, whenever we're told to write an equation, and it doesn't say what form, because as you all know, we've been working with 3 different forms the last few days. Point slope form, standard form, and slope intercept form. This is the most popular, the most common one, the default one. So if it says write in an equation, it's that one. It might not say slope-intercept form. We just know it's that one. And you're going to use 2 points. They're going to also give those to us. And we're going to do our magic with that. We'll take our 2 points. We'll find the slope, plug it into slope-intercept form, find the b, write our final answer. So we're going to do that right now. So this is where you definitely want to be writing the notes, because I don't think any of the stuff we just did is going to be difficult. This is the only one where you really have to show work. Okay? So let's look at example 2. So here's a table of values, inputs, outputs, x's, y's, okay? And it's displaying the cost of a boat in the years after 2000, right? And we have to write an equation. And then what that equation is used for is to make a prediction about how much the boats will cost later. So this is like real world. So people ask, when will I ever use this? This is real world application of math, okay? Where you can take some information, and there are mathematicians out there that's their job, okay? They take real world data, they create an equation that matches that data as best as they can for that line of fit, okay? And they can use that information to make predictions. Okay, so if I know all of this, can I predict what happens in 2025 or in any year? Okay, so that's what we're doing this for. So make a scatter plot, it's done. So those points were plotted for us, and a line of fit was drawn as best as they could. That's what they chose, okay? Remember, it could look a little different from person to person, right? Here's that step 3. We are going to write an equation, again, in slope-intercept form that goes through this point and this point. So we have an x and a y and an x and a y. Now, we know that anytime we have to write something in slope-intercept form, we need m and we need b. Sometimes those are given to us. Sometimes part of it is given to us. In this case, we're starting with 2 points. So let's practice this not using we'll just use their work here because I'm going to do one more with you. So look, here's that slope formula that you have to know, right? You have to know it. And all they did was second y minus the first y over second x minus the first x. They did all that work, got the slope. So m is 1528.8. Let's practice how to do this from there. So I have my slope that I just found, right? Well, they found it for us, but you know what I mean. Okay, so there's the slope. And remember, you can pick either point. It doesn't matter which point, all right? I'll use 5, 25, 1, 0. Okay, so you could have used either one, though. Remember that, doesn't matter. And so we have m, we have x, we have y. The reason I cross this out is because there's 2 ways you could go about this. You could use point slope form, but that's not how we've been doing it in class, so I don't want to show you another method. What we have been doing every time is plugging x, y, and m right in here, here, and here, and solving for b. And then you'll have everything you need, right? Because we have m, 1528.8, right? We found that. Now we're just going to use this information to find b. So I'm just going to plug right into slope-intercept form, like we have done a million times. Y equals m times x plus b. But Stolly, are you writing this down? Because this needs to be in your notes. And the steps here, guys, are the same. We've done this a bunch of times. You multiply these 2 together and move it to the other side. We're just solving for b, all right? So you pick up your calculator. So 1528.8 times 5 is 7644, right? And then I need to get b by itself. What would I do here? How do I get b by itself, guys? That's right. You subtract, Alan, the 7644, right? Because this is positive, we do the opposite. We should know this by now. I'm still getting people not knowing how to get a variable by itself. We've got to know that. And I just put that in my calculator. Lots of calculator work. 25108 minus 7644. And I now have my B value. And why did we do all that? Because you need M and you need B to write an answer in slope-intercept form. So the final answer would be y equals M x plus B. Now we're going to do one more together and do all the steps. So I just kind of shortcutted it there in this one. But we're going to do exactly the same steps. I would definitely write these in your notes so you have a really good example to look at. Plus, it's part of me checking your homework. Okay? So we're going to go to the next page, and let's start from scratch with this problem here. Okay? So ordered pairs given to us. There's the graph of them. Let's just go ahead and, they didn't draw the line. Do your best to draw a line through them. Not that hard with that one. It doesn't have to be perfect. It can't be perfect. Okay? And then it says use these 2 points. Remember I told you they would give us the 2 points and put it in slope-intercept form. So you say, okay, to put something in slope-intercept form, I need M and I need B. If I have 2 points, then I'm going to have to plug that into the slope formula. I mean, if you need to write it again, go ahead. I don't need to see this on your paper. I'm hoping you guys have this memorized by now. If you don't, you need it. Okay? So, like we've done a bunch of times, we make our fraction, and we do second y minus the first y. That goes on top. I mean, if you are using my method with these little arrows, you shouldn't be making mistakes anymore. And then second x minus the first x. And then you go to your calculator. 80 minus 20 is 60. 50 minus 10 is 40. And what I saw in first period was then students were getting stuck right here. They're looking at my key and they're like, that's not what I got for, my M is different from your M. Well, you're not done at this step. You still have to simplify that fraction. You just divide it. You can just do 60 divided by 40 or 60 fraction key 40. Remember, it's going to give you a mixed number sometimes. We know how to fix that. That's 3 halves. Right? I just got half of my answer. M is 3 over 2. Okay? This is important after that. All right, how do we find B? Well, pick a point. It doesn't matter what point we use. I'm boring, I just picked the first one, but it really doesn't matter. First point and your slope. So guys, X, Y, and M, that's 3 of the 4 letters that's in slope-intercept form. Plug them in and solve for the one you're missing. Y equals M times X plus B. X, Y, and M just plug right into slope-intercept form. And we have to know how to solve an equation for a variable. We've got some like terms we can combine here. When I do 3 halves times 10 in my calculator, 3 over 2, which is already on my screen, by the way, times 10, I get 15. How do I get B by itself? Subtract. If you got a negative there, could you get a negative? Yes, you could. If you got a negative 15, then you would add 15 to the other side, right? But this happens to be positive, so we would subtract. 20 minus 15 is 5. Now you have everything you need to write your answer. Y equals 3 halves x plus 5. Okay? So all of that is really review of what we've been doing. Now, there is one last thing we have to talk about, and that is using your equation to make a prediction. So remember I said in real life, there are mathematicians that their job is to do this kind of thing. They work for corporations, they take data, and they crunch the numbers, and they create ways of making predictions for, usually it's for future. So I didn't even read what this problem is about. Amount of milk a baby goat needs according to its weight. So as a baby goat gets bigger, it needs more milk, right? Just like a human, as you get older, you need more food or whatever. Okay, so all you would have to do now is plug in these values for x. So you would plug in x equals 17 right there. 3 halves times 17 plus 5. You wanted to make a prediction for a 55-pound goat, how much it would need, you would plug in 55 for x. So it's literally just plugging in that number. So 3 fraction cube 2 times 17, right, my x value, and then plus 5. So that goat would need so I'm going to just change it to 61 halves or 31 and a 30, what was it again? 30.5. You could change it to a decimal if you wanted to. Any of the answers would be fine for something like this. It would be multiple choice, so you would just have to make sure you pick the right one. And then plug in 55. 3 fraction key 2 times 55, and then plus 5. All calculator work. 87.5, you could write that. You could write that. You could keep going. Hit it one more time, you get the decimal. I thought that was the easiest way to write it, so that's why I did that. Okay, so after you get your equation, there will be a question, and you plug in the x value. All you have to do into the equation that you came up with. All calculator work, no work to show. Right? So let's go to the homework. Now, I only gave you one of these to do. You need to show the work for credit, of course. And it's number 6. So when you get to the homework page, 233, okay. All of the problems except for number 6 are just like what I'm going to do with you on number 1. So 1, 2, 3, 8, and 9 are exactly what we're going to review right here with number 1. Okay? So all of those problems are going to ask you, just like we did in the very first example, the real easy ones, determine whether each scatter plot shows positive, negative, or no correlation. If it's positive or negative, you're going to give me in words what it means. Okay? So this first one is calories burned during exercise. So we have time that you're exercising on the x-axis, and the y-axis is how many calories are burned. What would you guys call this? Positive, negative, or neither? Positive. Okay? So this one has a positive correlation. Okay? So you're going to say positive or negative or neither. Or no correlation. If you get positive or negative, then you need to give me some words. What are the words? Okay, as time what? Increases. It's always going to be the x is increasing, okay? As time increases, as the number of books borrowed increases, as weight increases, as the years increase, as you're going left to right, always on a graph. What are the y values doing? So as time increases, calories what? Calories burned, let me say that. Calories burned what? Increase, right? They're going up. So in your own words, using the stuff that's given to you, and I don't care about spelling or grammar, what does it mean? As time increases, the number of calories that you burn also increases. Okay? So you're doing 1, 2, and 3 are just like that. 6 is the one where you're going to use the 2 points. And you're going to show work finding your slope using either point, exactly what we just did, and then making a prediction, plugging in 25 for x into the equation you get, okay? So I'm going to give you the answers. You still have to show the work for these. No work, no credit. This is to write and interpret. Okay, and I didn't give you all the answers to the other one. Do you want me to check any of your other ones? More weight in lifting. So number 2, what would you say about number 2, guys? There's no correlation, right? So you can't say anything about it. That does not look positive or negative. How about number 3? Negative, right? So what are the words you say? Guys, X is always increasing, okay? So as the weight increases, what's happening to your repetitions? They are, what did you say? Decreasing, right? Going down. Increasing is going up, decreasing is going down. So as the weights that you're lifting increase, your repetitions decrease. That's what you're saying in words, okay? When you get to 8 and 9 on the next page, it's the same thing. You can say positive, negative, or no, and give your words. But number 6 is where we really need to concentrate and make sure we're showing all of our work, finding the slope, all that stuff. So find slope first. If you're not getting 16.1, you made a mistake. Don't keep going because the rest of it will be wrong. M, you should be getting 16.1. Before you divide it, different things. Yeah, he got what he wanted.
That's what I mean.
He knows how to play his game.
You're not going to put it back to you.
I told them I don't understand.
Wow. That's big of you.
not getting 16.1, let me check your work. Part B is now usage of the lemon defined at equals 25. So we're going to plug 25 in. So then, the equation, there's an x value. What are we going to put in for x? Yes. exactly as that. Something that's given 2 points, you start finding the slope. You do slope, you will find the slope. And you can get it 16 centimeters. That's the first step. Find the slope. Okay, so it's saying, you have to get this. So this, then you know all the years, but what's going to happen to 16 years from the top? That's the question. That's the question that I am. Or what will the price be of a home in 2025? Don't forget there's free tutoring after school on Wednesdays. So if you're not getting the help you need here, you've missed a lot of school or not watching the videos, you can always go to tutoring in the media center. Okay?